Right, so the language and logic of proof. This is a fairly long statement. So, right, a theorem. What is a theorem? It's a statement that can be proven. For example, Pythagoras theorem. If you don't know how to prove that, that's alright. There are plenty of demonstrations on the internet. Now, a conjecture, that's a statement that looks or that seems true, but has not been proven yet. So, for example, there is something called the Goldbach conjecture, which states that every integers greater than 2 can be expressed as a sum of 2 prime numbers. Now, well, that seems true. For example, we take, I don't know, 14, that's equal to, what, 3 and 11. Yes, 2 prime numbers. And this has been proven for number up to 4 times 10 power of 18, fairly big number. But it hasn't been proven for number greater than that. And so, well, that seems true, but hasn't been proven formally. Now, a statement, well, that's just simply an assertion. So, for example, 7 is a prime number. Or you can say another kind of statement is x squared less than 20. Right. A negating statement. Well, that's the negation of a statement. So, for example, the negation of x strictly positive is x less or equal to 0. Okay. So, the negation of statement P and statement Q, which are 2 different statements, is not P and, or not Q. So, for example, let's change column. X greater than 3 and x less than 5. Well, the negation is x less or equal to 3 or x greater or equal to 5. The negation of statement P or statement Q is not P and not Q. So here you see the alternance. Here there is an and here there is an or, here there is an or, and then there is an and. For example, x greater than 3 or x less than 5, where the negation is x less or equal to 3 and x greater or equal to 5. These two laws together, they are called Morgan laws, often used in electronics, weirdly enough. Okay. Symbols. Now we need to use a few symbols. So the first one to learn is this one, which is a knee a bit rounded, and that means belongs to. So for example, if we talk about the set of real numbers, we can say 5 belongs to R, which means 5 belongs to the set of real numbers. Another symbol to learn is this one, which means for all. So for example, for all x belonging to R, that means for all x real numbers. Then another statement is this one, so it's a E, a bit elongated, kind of symmetrical with regard to the y-axis, we could say, and that means there exist. Example. There exist n such that n square equal 9. Yes. Okay. Right, so these three symbols belongs to, for all, there exist. They often come back in proofs. Moving on. An example. What is an example? Well, I'm sure you know what it is, but it's say the statement is let n greater than 3. Well, example is n equal 4. Yes. Whereas the negation of a statement is n less or equal to 3. Now, conditional statement. Conditional statements. So let's say, for example, if n is a multiple of 10, then n is a multiple of 2. Often that can be written using this arrow here, with 2 bars. So for example, you say if n multiple, or actually maybe I should say, I'll get rid of that, n multiple of 10, that means implies n multiple of 2. Now you note that the arrow has one direction from the left to the right, because n multiples of 2 does not imply that n is a multiple of 10. Right. Let's keep going. The converse of a statement it's it's obtained by swapping the statements on either side of the implication symbol. For example, the original statement is n multiple of 10 implies n even number. Yes, okay, well that's what I said before. The converse of this statement is n even number, even, implies n multiple of 10. Now you will see that in that case this is wrong. This is true, but this one is wrong. Moving on. The contrapositive of a statement. So say if the statement is P, statement P implies statement Q. Well, the contrapositive statement is not P, not Q, sorry, implies not P. Example. It rains implies there are clouds. So the contrapositive contrapositive is that there are no clouds. So, okay, so basically I take the negation of the second statement. Therefore, it doesn't rain. Well, that's a non-mathematical example, but I could come up with a mathematical example. Well, let's do another one. Well, let's come back to the one. N multiple of 10 implies n even. Okay, well, the contrapositive would be n odd and not multiple of 10. Now, okay, so importantly, if this is true, then the contrapositive is true. So sometimes, if you are asked to prove the statement P implies Q, it may be easier to prove the contrapositive, because if the contrapositive is true, then the statement is true, and vice versa. Super duper important. Finally, so I've explained what these symbols means. It means implies. There is also a symbol that I've used actually and maybe didn't explain in properly before. This is this arrow, which has two ways, left and right, and this means equivalent to. So for example, 2x equal 10 is equivalent to x equal 5. If one is true, the other is true, and vice versa. Yep. So that's what I would stop there.